This is the third video in this sequence using RSLogix Emulate500. Specifically, using it in both the classroom and at home. So you can work on projects in your class where you have the hardware, the controller, then you save it to a memory stick, take it home with you, go into your laptop or your desktop and open up MicroStarter Lite, which is free, RSLogix Lite, which is free, and Emulate500, which is free. And then you take and convert your classroom project from whatever controller it was, assuming it's not an 1100, from like a 1400 to a 1100 or a 1500, 1200. But anyway, you convert it to either a 1000 or 1100 because that's the only thing that's supported by Emulate500. But you don't want 1000. You want to do 1100. And then you can work on your project at home and then save it on the memory stick, take it back to class with you, and open it up and convert it back to whatever controller you're using. That was all in the first two videos, actually. In this one, I'm going to enhance what I did in the last one that shows you how to create a template. So as you're going back and forth between two different controllers, you can enable a bit or disable it to make it behave more like a controller when you're in the emulate mode than it does on its own. So what I showed you before was fine, but I, in afterthought, decided that I can make it look even cleaner. So that's what we're going to do in this episode. And remember, this is all about people learning to program PLCs with the least expensive opportunity. I mean, without spending any more money than they have to. The software is all free from Rockwell Automation. You just have to go there. You'll have to create an account, and then you search on MicroStarter. You'll come up with it. You need links, RSLogix, and you need 500 Emulate. I also provide it on a product, the manual that you want if you want to do the projects that we're doing going through this course. This is the manual that you want. This particular one is more expensive because it includes a memory stick that has all the software on it, plus manuals and stuff. Now the software is free to download. My labor to find it, download it, put it on this memory drive and all the other stuff that's on there, it's not free. So, but you don't have to buy this manual with the memory stick. Instead, you can buy, it's the same manual, but it's less expensive. You can buy this manual and you can go through and do all the projects in this manual. Remember, there's 2 volumes, but I'm suggesting you only buy volume 1 to make sure that this is for you and that you like the way that I present this stuff. But you could do this on a SLC 500 or a MicroLogix 1000, 1100, 1200, 1400, 1500. The problem is, if you're going to do it on a SLC 500, then you have to have the expensive software, RSLogix 500. If you do it on any MicroLogix, you only need MicroStarter. And if you want to do it with the free software, MicroStarter Lite, then you need a 1000 or 1100, or you need to use the emulator. So it would behoove you to buy the manual, but watch the videos, go to the playlist on YouTube for RSLogix 500 or MicroStarter, and watch a few of them to see if you even want to do this. This is how we left it at the end of video number 2. We had created this template to use in the RSLogix Emulate500 on your computer at home or off-site from wherever the actual hardware controller is. And what we had done is we had created some program files. You automatically get ladder 2, which is this one, when you create a project. And ladder 2 is the only one that runs automatically. All the rest of them, you have to have a jump to subroutine instruction to get to those. So we created ladder 3 that we called main, and there's nothing in main. That's where you're going to put your main program. And then we had 253, we call that HMI. And remember, we had placeholders at the end of the rungs. So you could click on these, or you could look to see what the state of your I/O was like you would on an HMI. I realize it's not graphics, but it is kind of a poor man's HMI. And then we had setup, where you went in and you selected what form you wanted each input to be, a maintained switch, normally open or normally closed. And I explained all that in video number 2. And then in the inputs file was the logic that facilitated those inputs as behaving as maintained or normally open or normally closed. Keep in mind, with the emulator, there is no I/O scan because you're using RAM on your computer to emulate a RSLogix 1100. So the emulator does not scan the input modules for the state of those input points or transfer data out to the output modules because there are not any. But the memory locations are still there for you to use. So I took this one, the way I left this. So in ladder 2, you had the JSRs. These 2 routines right here, setup and inputs, you don't want to run these if you're using an actual controller because they will mess up your code. So if you're going to run the emulator at home, you right click, toggle that bit on, and then it runs these 2 program files, if you like, these 2 subroutines. And if you're actually working with a controller, then you toggle these bits off so they don't interfere. And then in the main, there was no code because that's where you're going to put the code that you're going to run. However, in thinking it through, I decided to change it up a little bit. And actually, I changed it twice, but this is the first time I changed it. Notice that I created another ladder file called control. And so in main 2, which is where you would normally put your code, I have a JSR to go to 250, to subroutine 250 right here. So if I go to control and open that up, so in other words, when you're in ladder 2, you execute this wrong, it leaves the main routine at that point and goes to that routine, and then in that routine, it runs these subroutines. And we don't need a ladder 3 anymore. So since that's selected, I'm just going to delete it because we don't have a ladder 3 to jump to. So that was kind of an intermediate thing. I forgot to delete it. So this is what you're left with in your control subroutine, which means from the main routine, you're going to JSR to 250 and you're going to execute this code. But when the code executes, it's going to jump to 253, come back to here, jump to 254, come back to here, jump to 255, come back to here. Then it's done and it goes back to ladder 2. What I decided to do was to eliminate these 3 routines, HMI, setup, and inputs. Now I'm just going to eliminate setup and inputs. I'm going to put that in control, and I'm going to leave the HMI, but I think I'm going to put that in a different ladder number. All I'm doing is editing stuff. I'm going to pause and then come back with what I did. Okay, now this is how it looks. If you look over here to the left, you'll see that I have quite a few less. I've reduced the number of routines, and I have ladder 2 back being as the main routine, which is the way you're going to find all the projects in the lab manual, rather than ladder 3, which I kind of showed you in the last session. So ladder 2 is back to being what it should be, but there are 2 rungs in there that you might as well keep to the bottom of your program. The first one is the bit that you want to toggle on if you want to use the emulator, and toggle it off if you're actually working with a real controller. It jumps to 250, and in 250 is all of the code that simulated the inputs as normally open, normally closed, or maintained. And then we left the HMI as a separate routine that you can add stuff to, and you may never even use this. But it's kind of a template, so you can go in and toggle your inputs on and off, because remember, when you're using the emulator, you don't have lights and switches. So in the main program, you have 2 rungs of logic in your template. And all the code that you write will be above this in your lab projects. It really doesn't matter where these two rungs fall, but to make it look neat, I would put them at the end, because remember that this emulator enhancement is not part of the code for your project. So we're trying to keep it out of sight. So this kind of cleans it up a little bit. So all the code that was in 254 and 255 before is now in 250. I also added page titles. That way, when you're troubleshooting, and you should never have to troubleshoot this code, okay? So if you're in the main program and you got code in here, if you see a plus sign over here next to one of the program files, that means that we have enabled advanced diagnostics right here. You go to Tools, System Options, or Tools and Options, and you can turn on Advanced Diagnostics, Integrate Advanced Diagnostics in Project Tree. What that does is any page titles that you have, and remember, page titles is strictly for organization. See, it's broken up here. So if I click on Real I/O Simulation, it takes me right to the Real I/O Simulation here. If I go to Input 7, it takes me down to Input 7. So you should never have to do anything with this code down here, ladder 250 and 253. And it doesn't matter what those ladder numbers are. It could be 3 and 4. But in order to keep things tidy, I push them all the way out towards the end, meaning, 255 is the highest number. And so this could have been 254. I just do it to get it out of the way so it looks clean. So this is, sorry if you already went through and created your template before. So this I call if you look at the title up here, RSLogix 1100 Emulate Template Plus. So it's kind of an upgrade to what you did before. So we did some things in this that you weren't familiar with if you haven't learned PLCs yet. But it would behoove you to download the free software, see what you can do on your own, go watch some of the free videos on YouTube. And by the way, the YouTube list, let's see if I can get to it. Content, playlists, and we want to go right here. RSLogix 500 Micro Starter. So there's your playlist right there. Click on videos, and there's the first lab project in the manual. However, down at the end, and you'll have to go more than 30 down. If you go all the way down to the end, you'll see some videos. The first two that you pay attention to, what is a PLC part 1, part 2, watch those before you do anything. And then you can start looking at RSLogix 500 Emulate. That's just an overview of it. And then we've got part 1 and part 2. That's an overview of the Emulate500. And these are actually describing how to use it to go back and forth, change the properties from, say, a RSLogix 1400 to an 1100, take it home, use it on the emulator, and then come back to class, open it, change it back to a 1400, and do your lab projects in class. And this second one is creating that template. And once you create a template, you don't overwrite it. You save it. And anytime you want to do a project where you're going to involve the emulator, open up the template and immediately save it as the name of the project you're going to do. That way you don't booger up your template. Now, I'm going to add a third one to this list, and that's the one we're doing right now. Thank you for listening. Have a good day. This is a quick slide through the manual. This is volume 1. Just volume 1. There's 2 volumes. Volume 1 is what you need to start. And if you go on PLC University website or plcprofessor.com, you can go to the actual product and it gives you screenshots and the table of contents. So you can peruse through the table of contents. Welcome to the course. It talks about what kind of controller to use and a digital field device simulator, getting set up. And then there are a number of pages of technology and explaining how PLCs got to where they're at. Talking about continuity, talking about relays and the symbols. And there are a number of fill in the blank spots throughout these manuals. And I do have an instructor's guide available with all of the answers or my opinions of what goes in those blanks. It's about a 70 to 80 page document, and it's almost finished. It will be available for instructors in class. Then hardware, digital field device simulators, and analog field device simulators. You don't need to buy mine. There's complete instructions available to buy your own parts, make your own box and do it yourself. So we talk about hardware, and that includes, of course, RS-232 is kind of disappearing for USB, Ethernet, serial communications, then how to create a project, navigating, editing, programming data files. And you can see it's all step by step. And again, there's a number of fill in the blank, and there is a instructor's guide that will be available. But if you're not an instructor and you just buy the manual, all of the answers for these questions are in the videos, the playlist that's on the PLC Professor YouTube channel, and it's free. I would advise you to go in and watch some of those videos to see if you even like what we're doing, and then buy the manual. I'm just kind of breezing through it here so you can see what it looks like, and it's all step by step. I don't think I've left out a single step anywhere. Now later on, I thin out how much step by step I give you, because at that point you shouldn't need a step by step for certain simple things. So this is volume 1. All these graphics I created, some of them are screenshots, like the logic on the left, those are screenshots. And the graphic on the right, that's something that I created and is also in the videos. Challenge part 1, that's a 3 conveyor little project, and we have you write some code to control it. So volume 1 is more about the basics than it is about programming applications. But there are applications in here. Here's an application where you're using a one-shot instruction to detect certain things, cart movement on a conveyor. Very popular in material handling. A lot of jobs out there for material handling. Timer data types, a practical application with a retentive time delay timer. And I know I'm kind of getting ahead if you're just starting into this. Logic to detect a sluggish cylinder. In other words, you commission the project and you kind of recorded how long it took the cylinders to extend and retract. You put that in the code, you turn it loose, and then sometime later, if the cylinders are starting to slow down, it could be the operator is messing with the flow control to have more brakes or something. Who knows? But anyway, it's a practical piece of code. Counter data types with a little conveyor application. I tend to use conveyors a lot in the more basic stuff because everybody can visualize a conveyor with cartons flowing on it. Comparison instructions. You will use some of these, but the main thing is if you are going to maintain systems, electrician, technician, or shop floor engineer, you have to interpret the code that everybody else writes. So you need to have at least a light familiarization with all of the comparison instructions and the math instructions. Move is a very popular instruction. There's a move with mask. Shift registers. We don't encourage people to use shift registers anymore, but you're going to find a lot of installed controllers out there that have shift registers in them. So you need at least a fundamental grasp on how shift registers function. They're actually not that simple to program or to follow. So it's well worth your effort to learn. Sequencing, light programming a sequencing, but we're leading up to something in volume 2 that's a major project with a lot of sequencing in it. So we're introducing sequencing here. Now in the appendix, there's a section on Boolean algebra. And Boolean algebra, George Boole, a Scottish theologian, he basically authored Boolean logic. Means everything can be broken down into a binary choice. And these are the laws of binary algebra, and there's little projects you can do. There's also De Morgan's theorem, and that explains some of the simplification and contraction of code into the simplest form. And then I show you, there's a couple pages here on building a training station. Now, I don't recommend using a 1000, but you could build this exact same station with an 1100. It's about the same size. It's a controller, and it's a box with lights and switches and a power adapter. You can put it in your bag and take it to Panera Bread or Starbucks, plug it into an outlet and sit there, work on your project. So this is the very first learning station that we worked with a RSLogix 1000. But this same material applies to any of them. So see here, I show you how to build it yourself. And if you buy the kit, you'll get more detailed instructions. We put RSLinks in the back because RSLinks is something that you're going to use over and over again throughout your career, and you'll be looking for it. So we put it all the way in the back so it's easy to find. There's a little bonus section here on setting up a PowerFlex 525 using Connected Components Workbench. And that, my friends, is all the way through the manual to the end.